Let's say you wake up one morning, look at the globe on your desk, and something's off. Your globe, the same one you've had since 3rd grade, is now a cube. Not a cube-shaped display or a funky sculpture. No, the entire Earth is a perfect cube. Flat faces, sharp corners, straight edges. And that's when it hits you. Gravity feels weird. You're not standing down anymore, you're standing slightly sideways. But let's rewind a little. What would actually happen if Earth were a cube instead of a sphere? First of all, let's be clear. Gravity does not change just because we change the shape. It still pulls toward the center of mass. And in a cube, that center is still in the middle, just like with a sphere. So if you're standing in the exact center of one of the cube's 6 faces, life might feel relatively normal. Gravity pulls straight down beneath your feet, the sky looks right, and you might even believe everything is fine. Until you start walking toward the edge. As you approach the corner of the face, gravity begins to betray you. It still wants to pull you toward the center of the cube, but the surface you're standing on is now curving away from that pull. To stay upright, you'd have to lean. Lean more. A little more. Until you're walking like you're on the side of a steep hill that just keeps getting steeper. By the time you get to the edge of a face, or worse, the corner where 3 faces meet, gravity is pulling you diagonally through your shoes. You'd feel like you were being dragged sideways down a slope you can't even see. And if you slipped, you wouldn't roll gently downhill. You'd plummet off the edge, launched by your own confused sense of balance into what can only be described as one of Earth's 6 very awkward cliffs. But the real nightmare begins with the atmosphere. On a spherical Earth, the atmosphere forms a more or less even shell around the entire planet, held in place by gravity. It's cozy, breathable, and wonderfully insulating. On a cube-shaped Earth, not so much. Air, just like people, follows gravity. So it would naturally migrate toward the center of each cube face, the areas closest to the core. The edges, and especially the corners, those would be high-altitude wastelands. The pressure would drop, temperatures would plummet, and the air would thin out dramatically. In other words, only the central zones of each face would be habitable. The rest of the cube would be a kind of windy, icy hellscape. Imagine walking from the center of a face to the corner. You'd be climbing into an artificial Everest, created not by mountains, but by geometry. Ocean water would behave the same way. It would flow toward the centers of each face and pool there, forming 6 isolated, circular oceans. The ridges around each face would become towering coastlines, like the rim of a giant bowl. Crossing between them. Not going to happen without hiking over an edge that's thousands of meters high and mostly uninhabitable. But let's not forget the weather. On normal Earth, our weather is driven by the Coriolis effect, ocean currents, and the way sunlight hits the curved surface. On Cube Earth, sunlight wouldn't move in a smooth arc across the sky. It would hit one face directly, while the other 5 sit in various levels of shade or complete darkness. The corners would get very little direct sunlight at all, and the way heat is distributed would be, to put it scientifically, a complete mess. Some parts of the planet would become scorched deserts. Others would be permanent ice fields. And thanks to the sharp edges and massive temperature gradients, weather systems would go absolutely feral. Think massive wind shears, rotating vortexes forming at the cube's edges, and thunderstorms that sit on corners like angry, floating gods. Also, Earth spins. That's a problem. A sphere has nice, even inertia. A cube, not so much. The uneven distribution of mass would make rotational stability a nightmare. The planet might wobble like an unbalanced washing machine. Tectonic stress would build up where the faces and edges try to adjust to the impossible demands of a spinning cube. Earthquakes. Expect lots of them.